Okay, I think we can get started. So, good morning, everyone. Welcome to the GIS Sea Level Rise seminar. We're very glad to have Dr. Hannah Baranes, who is an assistant research scientist and head of the Coastal Dynamics Lab at the Gulf of Maine Institute. She uses a combination of observational, statistical, and numerical techniques to characterize coastal and estuarine flood risk. Her work also supports translation of sea level rise and flood hazard science to coastal planning, flood forecasting, and state rulemaking. She is also a member of the Maine Climate Council's Scientific and Technical Subcommittee. Prior to her current position, Dr. Baranes was a postdoctoral researcher at California Polytechnic Institute and GMRI. She earned her BA in Earth Sciences from Dartmouth College and her MS and PhD in Geosciences from the University of Massachusetts Amherst. And today she will be speaking on the topic developing localized, accessible, and actionable flood risk information for and in collaboration with Maine coastal communities. So welcome, Hannah.
All right, thanks for the introduction, Patrick, and thanks to those of you who called in today. I'm going to share my screen. All right, are you seeing the slides okay, Patrick? Great, okay. So like Patrick said, my name's Hannah Baranes. I'm a research scientist at the Gulf of Maine Research Institute in Portland, Maine. And like Patrick said, broadly, I study the physical drivers and impacts of changes in mean and extreme coastal water levels in the Gulf of Maine, but I'm actually not really going to talk about any of that today. Another part of my job is collaborating with government practitioners, educators, et cetera, to translate science in support of various types of coastal adaptation measures. This is work I've just been doing for a few years, and it's been a really interesting challenge because, as you all know, we're often working with information that's maybe uncertain, not spatially continuous, and constantly evolving as science progresses. Yet we need to apply it to make really concrete and specific decisions. So I'm not sure if any of you have tuned into any of the other talks in this seminar series, but they've been talks about meltwater drainage, fracture, flow of ice sheets and glaciers. So I'm going to talk about something quite different, which is what happens well after those sorts of fundamental advances in our understanding of ice behavior make it into Earth system models, then maybe into the ensemble of sea level projections for an IPCC assessment report, then make it to the US Interagency Task Force sea level report. So then I'll talk about how that sort of information gets adopted by a state and provide some examples of how that information gets applied locally. So let's see. Oop. Maybe the arrows will work. There we go. So that's actually the third thing I will talk about today, the local adaptation of sea level rise projections. First, because much of my work is regional, I think, and when we're talking about kind of specific applications of science, local context is really important. So I'll give some local context on drivers of coastal water levels in the Gulf of Maine. There's also been this recent, really interesting couple years of high sea level in the Gulf of Maine, which I figured would be interesting to show to this group. I'll talk about applying the sort of coastal science to near-term flood forecasting, and then get into local application of sea level rise projections to future planning. So as a starting point, I work at this place called the Gulf of Maine Research Institute. It's a bit different than being a researcher in a university. We're a nonprofit institute located in Portland, Maine. Broadly, our mission is to develop and deliver collaborative solutions to global ocean challenges. So yeah, what in the world does that mean? We have a research division, which with research labs that function kind of like academic labs. We have physical sciences, ecology, biology, coastal and marine economics, learning sciences, and we do research that tends to be regionally focused but globally relevant. And I think what's really unique to working at GMRI is the acronym that we use, is that we also have an entire impact division, which is full of community engagement specialists and educators and people who work, like, for example, with the seafood supply chain from the consumer to the regulatory level. And we partner between kind of our research labs and our impact programs to try to achieve essentially these four initiatives. So we work on adapting fisheries and seafood. I mostly sit in this kind of building climate ready community space. We do projects around blue economy and supporting working waterfronts, and finally energy solutions. So that's a bit about where I work. Since this is a NASA-hosted seminar series, I just wanted to give a quick shout out to NASA, who funds a lot of our really great a lot of the great work our education team does. We have this program called Lab Venture that serves 9,000 Maine students annually, and NASA Science Activation funding helped us improve the program so students can actually interact with sea surface temperature data from NASA satellites to investigate the changes that result from warming trends in the Gulf of Maine. And NASA supports this network of educators that gets together, like about 600 formal and informal educators to support them in delivering science learning in their communities. So thanks to NASA for all the great impact that they've had in Maine. All right, so let's start by talking about the Gulf of Maine. I'm going to drag the screen down here so that I'm not, okay, great. So the Gulf of Maine, and specifically the Bay of Fundy, has the largest tides in the world. The Gulf of Maine is this part of the Atlantic Ocean that extends from north of Cape Cod all the way northeast into the Bay of Fundy. The tidal range, if you're south of Cape Cod and this area called the New England Shelf region, tidal range is less than 2 meters, but as soon as you enter the Gulf of Maine, the southern part of the Gulf, tidal range is about 3 meters, increases to 6 meters at the kind of entrance to the Bay of Fundy, and then reaches 14 to 16 meters all the way in these northeastern embayments. And those are the largest tides in the world. It's for a few different reasons. The actual geometry of the Gulf is roughly resonant with the frequency of the M2 tidal constituent. It's also a shallow and narrowing embayment that curves to the right. So kind of the funneling of water and Coriolis amplifies tides within this kind of confined bathymetry. And another sort of key feature of coastal water levels here that's different from kind of the rest of the eastern US is that our flooding is primarily driven by extratropical cyclones, whereas if you go south of Cape Cod, most extreme floods are driven by tropicals and then more routine flooding by extratropicals. And this is a kind of key thing to how we think about flood risk in this region. And later on, I'll explain why. But in practice, what that means is if I grab the top 10 water levels ever recorded at the Eastport tide gauge and then the New York City Battery tide gauge and plot them relative to highest astronomical tide, that's the highest water level can get just from tides, so no meteorological impacts. You can see that in Eastport, water level doesn't go a whole lot higher than highest astronomical tide, even for the most extreme events we've ever had. Just because extratropical cyclones are these big, slow-moving storms that tend to have lower maximum wind speeds, and they, compared to tropical cyclones, which can, if they make landfall in the right place, like Hurricane Sandy did in 2012, they can really drive large storm surges. So that's just less of kind of a consideration around flood risk in the Gulf of Maine. So another way of looking at this is a diagram I often show when I go in to give community presentations and try to talk about, like, well, what are the drivers of flooding in the Gulf of Maine? We have both the long-term rise in sea level and year-to-year sea level variability that controls water level. And that, depending on where you are, that might be big or small relative to our tidal range, which can raise and lower water level 10 to 20 feet per day. What's important to note here is that tides are relatively big relative to storm surge in the region, again, because we're mostly being impacted by extratropicals. And then depending on where you are, there might be, if you're up in a tidal river, which we have many of in Maine, you might have freshwater effects, or if you're on an exposed section of the shoreline, wave run-up effects can contribute to flooding. So something really important that's been happening in the region recently, this is annual mean sea level from the Portland tide gauge, which has been this is a co-ops tide gauge that's been in the harbor since 1910. There's this big spike in sea level in 2010 that's been written about a fair bit in the scientific literature, but then again in 2023 and 2024 we had another high sea level anomaly that's just started to come down in the last couple of months. So just want to make the important point here that this is not annual sea level here. This is just January and February of 2025. Um, we have not looked into the specifics of why this is happening. Kind of similar to the 2010 spike in sea level, it seems to be largest in amplitude and the signal's the largest in the Gulf of Maine, kind of reduced in the mid-Atlantic region, and then not detectable south of Cape Hatteras. But again, we haven't looked into why it happened. An important thing to point out is that in January of 2024, sea level was up here. It was kind of one of the top three highest monthly sea levels ever recorded. And I'd imagine folks on this call, this is the kind of information you look at all the time, but to give a sense for what the local impact of this sort of, I guess there's a roughly 8 centimeter increase in sea level over a year can have in a region. We had these two extratropical cyclones that impacted the Maine coast on January 10th and 13th in 2024. And by some estimates, 70% of our working waterfront was damaged or destroyed. There were other things that contribute to the kind of severity of the flooding impacts in this event besides the high sea level, but that 8 centimeter bump in sea level was like a pretty big part of just making the inundation effects so severe. Another kind of interesting thing we found about it is that, and this is something we're looking into in collaboration with the National Weather Service, is that most of the extratropical cyclones that hit this region, they follow tracks that are slightly offshore. And so they drive northeast winds from the northeast onshore. So they're often called nor'easters. Sometimes extratropical cyclones, they'll follow tracks that are farther inland, and this low that sits over land drives winds out of the southeast. On some parts of Maine's coast, the next landmass you hit, if you draw a line out over the ocean, is Brazil. We have like an incredible amount of exposure in that direction, and just these sou'easter storms can whip up these giant waves that have absolutely devastating effects on the coast. So we're trying to understand the basic climatology of these events, what kind of coastal impacts are connected to them, and if there's any relationship with large-scale atmospheric circulation patterns. That's a bit of an aside, but kind of a important thing to note about these events. As you might imagine, it led to a pretty dramatic increase in high tide flooding. This is Portland Pier, located on Commercial Street in Portland. We had I pulled the number of days that crossed the flood threshold for this pier. We had 18 days in 2023, 29 in 2024, and historically, it's kind of just had a small handful of them. And then one thing that's been really interesting talking to folks around the Maine coast is that people have really noted, I mean, 8 centimeters doesn't sound like a lot, especially for an area that has such a large tidal range, but we have a lot of people in Maine who work in intertidal environments, and it's had a pretty dramatic increase on a pretty dramatic impact on the number of low tides where, for example, wild shellfish harvesters can access the intertidal. And people working on salt marsh restoration projects have noticed a pretty big increase in inundation. Okay, so that's a bit of context about about coastal water levels and sea level in the Gulf of Maine. So I kind of came here at a very interesting time when there was, because of these storms, there's been a lot of interest in essentially coastal adaptation. So it's been great being here. There's all this momentum. So next I'll talk a bit about near-term flood forecasting. So the first year I was here, there was another decently big flooding event that hit in December of 2022. And these photos are showing just kind of some of the impacts we saw at the coast that seemed relatively avoidable. So, for example, on this upper picture, I think I did have a pointer. Well, this is Union Wharf in Portland. You can see these exactics floating around. There's a propane line that snapped. We had a furnace get flooded. All kinds of stuff getting dumped in the harbor. And by necessity, these sort of like working waterfront areas, they have to be close to the coastline. And so like they have to be close to sea level. They're never going to be able to be elevated way above sea level because the people who work there have to interact with the water. So it's pretty key for areas like this to have a sense for what water level is going to be like and what the impacts are going to be when coastal flooding events are coming. This is a small fishing co-op in the mid-coast area of Maine. I talked to some fishermen here. They said they lost tens of thousands of dollars of bait just from kind of the barrels being sitting too low and tipping over. So these are relatively kind of avoidable impacts. So I decided to try to learn a bit more about coastal total water level forecasting, and the National Weather Service does put out a coastal total water level forecast. One thing you'll notice about it is that the only place they release forecasts, despite using hydrodynamic models that put out spatially continuous output, they only release forecasts at these kind of select points. It's estimated that Maine has like 5,000 miles of tidally influenced coastline, so a lot of places where this sort of information would be helpful, and we don't have it. So they put out forecast points in areas where they know the area really well, or like they know that there's something really vulnerable there, or where there is a tide gauge to manually bias correct the forecast. So to dive a bit into what that means, here's one of the handful of models that or model ensembles that the National Weather Service in Gray, Maine uses for flood forecasting. So the red line is showing observed water level at the Portland tide gauge. The gray is showing what's forecasted. This pink line is present for when I pulled the screenshot. And so what they do is they look at over the last 3 or so tidal cycles, how did the forecasted water level that put out by their model differ from measured water level at the tide gauge? And that's what they're calling the anomaly. That's this green line. So then what they do when they put out a forecast, they check what was the anomaly over the last 3 high tides, and they use that to kind of to essentially manually bias correct their forecast. So they tend to prefer to put out forecasts only in places where there's a tide gauge. So kind of the other end of this challenge, this is a slide I sometimes show kids when I go to talk to them, is that if the National Weather Service puts out a flood forecast saying water level is going to be 13.5 feet on Tuesday, if you're sitting, if you're an emergency manager in Knox County, which is a coastal county in mid-coast Maine, or someone on the municipal staff, you'd be wondering, well, what does 13.5 feet mean for us? Like, what roads do I have to close? And so the real power in having this kind of information, kind of the combined flood forecast plus information on local impacts, is that you can really prepare well for these sorts of events. So as an example, this is the picture I showed you before of this is the same place, Union Wharf in Portland, where I showed the picture before of all the different kind of things floating around. We've been working with the managers of this working waterfront area to go in and survey / measure the heights of all of their utilities and flood vulnerable assets. And when a forecast comes out from the National Weather Service, we can give them an inundation map and kind of on a utility by utility basis say, this is what's below the forecasted water level within a foot and more than 1 foot above it. And compared to this event in 2022, when this January 13th event, this was the flood event of record that happened just about a year later, we saw that Tim and Alec, they're the 2 people who manage this working waterfront. They had a plan to communicate with their tenants and clean up loose things on the wharf. They disconnected propane tank lines and electrical, so no floating propane tanks or gas leaks or fire hazard. They had elevated some of their heating systems and were out there with temporary lines securing like dumpsters and exactics from floating into the harbor. So we were wondering, essentially, how can we bring this sort of information on a more kind of general level to more coastal Maine communities? There's this great program from the National Science Foundation called the Civic Innovation Challenge. If you have a kind of applied community problem that there's technology to address and you can pilot it within a year, they'll give you some money to test it out. So our goal was to pilot a process in 4 coastal Maine communities that supports translation of coastal water level and flood impact data for flood adaptation and intergenerational engagement. So there were a lot of elements to this project, which I'll walk through piece by piece. First, I just want to mention it was a pretty massive effort. So this is absolutely not something I did alone. I had a lot of great GMRI colleagues, kind of community partners and government partners in executing this work. So the first thing we did is because we realized we can expand flood forecasting if we install tide gauges. We partnered with this startup that was launched out of Brian Glazer's lab at the University of Hawaii called Hohonu. They build these low-cost tide gauges that a lot of labs or research projects like this will build themselves. It was great to work with them because they do things like if the cellular network changes from 3G to LTE, they'll send you a new sensor that has LTE. They handle kind of the data pipeline and storage, which is really great. So we installed these low-cost sensors in 4 coastal Maine communities, and this map on the right is just showing kind of since we installed those 4, how this project has kind of served as a blueprint for further expanding the network, which has been really exciting, even again, just starting with 4. We installed a combination of ultrasonic gauges and radar gauges. So this PVC houses a little bit of onboard data storage and telemetry pieces, and then there's a little sensor on the bottom that's either this one's radar or ultrasonic, so it sends a signal down, bounces off the water, measures the time that it takes to come back up, and gets a water level. Then kind of on what is the impact of forecasted or measured water level? We partnered with the 4 communities we were working in to identify sites that they were particularly concerned with around flooding. And we call these coastal flood monitoring sites. And this sort of the challenge in establishing a relationship between water level and local flood impact comes from these flooding events happening everywhere at once. And so the National Weather Service can't really get eyes on, or a municipal manager can't really get eyes on the ground everywhere to know what local impacts are. So that's a really great opportunity to use community or citizen science. So we worked with the National Weather Service to come up with a protocol where we send people out either kind of as a part of a classroom individually or as part of an event hosted by the community to go out and make observations and take photos and describe weather conditions around flooding events. Partnering with community-based organizations was great. Again, as GMRI, we can't be everywhere at once. It's not sustainable to be running these sorts of programs throughout Maine. So our climate engagement team developed signage, brochures, social media templates, and facilitator guides to get organizations in those communities running these kinds of events on their own. And our education team developed kind of a whole curriculum around this project because youth involvement is absolutely critical in any sort of, in my opinion, any sort of community engaged climate project. So it's a 3-part curriculum where they learn kind of some of the basic science around sea level rise and coastal flooding and coastal adaptation planning in Maine and in their communities. They get out and make observations during some of the predicted high tides of the year. Then we found out they actually also really wanted to go out during low tide because they had trouble believing that a place could look so different just 6 hours later. And then my absolute favorite day of work I've ever had is when a whole bunch of 6th graders in Portland came into GMRI with people from the Portland Sustainability Office and their parents, and they presented the observations they've made along with proposals for solutions for sea level rise adaptation. So this is an open source and standards aligned curriculum that's available at teach.gmri.org. So definitely encourage you to take a look if it's something you're interested in. And then kind of the final piece is getting all of these observations. I think since we launched this project, we've had maybe 6,000 observations contributed to the project, bringing them all into this online data platform where if you're the National Weather Service or some sort of a municipal planner, you can filter through the observations by severity of flooding, the type of site it is, where it is, the dates, and you can pair essentially these observations of water level impact with tide gauge measurements. So the next thing we're working on here is sifting through those observations. This is work that this fabulous intern from the University of Maine, Sarah McCullough, is working on, kind of sifting through those observations and finding ones that have imagery of a really good high watermark, and then going to either sort of using a combination of in situ elevation measurements with a GNSS system or and LiDAR to try to estimate the local elevations of high water marks during some of our flood events of record. The reason this kind of thing is really helpful in Maine is that there are people at GMRI who do things like write climate vulnerability assessments for communities or for individual working waterfronts to support adaptation. And what we find in reality sometimes, like let's say we were working on one of these things for this community down here called Tremont, which is one of the most flood vulnerable areas in Maine. Geographically, it's really, really close to the Bar Harbor NOAA tide gauge, but when you actually look at the areas that are vulnerable to flooding, they might be facing a different direction or have really kind of complex local features like shallow embayments or tidal restrictions that make it really hard to use a tide gauge that might only be like 50 kilometers away to quantify flood risk. So what we can do then is we can we can sort of assess flood risk using water levels from things like FEMA maps or the nearest tide gauge, and add sea level rise to them. But it's much better when we can grab a photo from, again, this sort of in the beginning why I showed that we don't have like a kind of the types of events we've seen already. They're pretty representative of a good design flood event. We don't really have to worry about a Hurricane Sandy coming. So it's really great to use local knowledge and documentation of recent flood events to kind of use as a design flood event in tandem with imperfect data sources that are out there. And that's what this is showing. So this is mapping elevations of different utilities under 2017 sea level conditions relative to tidal elevations, the FEMA 1% still water elevation, but then we can do something like plot the height of the January 13th event. And sometimes we find that these two things really don't match well. Okay, so that's part two. Talked about near-term flood forecasting. And finally, let's talk about local application of sea level rise projections. So there are quite a few states out there that have codified, they've incorporated sea level projections into local planning. And here's the way Maine has done it. So this all happened before I started working in Maine, but after the 2017 NOAA sea level rise scenarios came out, Maine went through its first process of writing a report of local impacts of climate change in Maine, and then using that to inform our first 4-year climate action plan. So this technical report that underlies our climate action plan used Sweet et al. 2017 to come up with planning scenarios, sea level rise planning scenarios. So STS, that's the group that writes this report. The STS recommends that the Maine Climate Council consider committing to manage for likely sea level rise associated with the intermediate scenario from Sweet et al. 2017. Additionally, because of the evolving science regarding potential future contributions by the Greenland and Antarctic ice sheets, the STS recommends preparing to manage for a likely range of sea level associated with the high scenario from Sweet et al. 2017. So in practice, what this looked like was having these commit and prepare to manage scenarios of relative to 2000 sea level, 1.5 feet or 3 feet in 2050, and 4 or 8.8 feet in 2100. And so to give you a sense for what that looks like relative to the updated 2022 scenarios from the U.S. Interagency Task Force report on sea level rise, these lines and shaded regions are showing the median and likely range for low, intermediate, and high for Sweet et al. 2022. The circles are showing Maine's commit to manage scenarios. The triangles are showing Maine's prepare to manage scenarios, which now fall, and that the updated projections fall outside the likely range for the new high scenario. And when I first arrived in Maine, fresh out of graduate school, my thoughts were, oh, but these sea level rise projections aren't localized. Like this is just a statewide average, and everyone's going to be confused about the year 2000 baseline. And AR6 was coming out, so I was like, the high scenario is going to be confusing in the context of AR6. So like, is this a good idea to be kind of like giving these general benchmark numbers? But what I found when I got here was that a lot of good came out of these really simple numbers. So 1.5 and 4 feet are a one-liner in every news story and community event about climate change. You can be talking to a marine contractor and they'll be saying like, oh, I saw what happened in the January storms and now I'm thinking about what's plus 1.5 and what's plus 4. And so the way that's kind of played out on the ground is that as people are starting to like rebuild, those are numbers that are kind of locked in their minds as this is what it looks like to plan for the future, whether or not they've got the right baseline or they're exact. And so kind of some of the more formalized ways these numbers have played out. Before I get there, recently we did a 2024 update that used the 2022 U.S. Interagency Task Force to kind of provide updated information. And we thought a lot about how we could try to maintain like the really important simplicity of those numbers, but kind of reflect the evolving nature of science. And what we landed on was saying that Maine's, rather than kind of adjusting the 1.5 and 4.0 to some like decimal points that were slightly different, we decided to say that Maine's commit to manage sea level rise scenarios remain within a statistically likely range of the equivalent scenario and updated projections. And then for the prepare to manage scenario, we said that they should just be shifted 2 decades later to 3 feet by 2070 and 8.8 feet by the 2120s. And then we kind of provided a more step-by-step guide to saying when you're actually applying these scenarios to localized decision making, here's a table of the really awesome gridded projections that are on a kind of a 1 degree grid that are provided by the 2022 technical report. And to talk a bit about how the actual sort of like specifics of this has played out, in 2021, we had Maine passed Public Law Chapter 67 that requires 7 state agencies to incorporate commit to manage sea level rise scenarios into state laws and rules. And just to give 2 examples of what this has looked like, kind of the first time we really had to grapple with like the detailed implications of having a rule like that was this collaborative project I did with Maine Department of Environmental Protection, where they were interested in developing a required NHRA natural hazard risk assessment process that these terminals have to go through every 5 years for permitting. And adding in that they have to consider Maine's commit to manage sea level rise scenarios on a future 30-year time horizon in order to get permitted. And again, we were kind of faced with the challenge of like, gosh, there's not perfect site-specific information, but let's do the best we can. And so we worked with a working group of NOAA folks, scientists like me, marine terminal oil owners and operators, their consultants, and representatives from the communities that these terminals are in Maine to agree on this approach that could be updated as kind of science and more locally specific modeling products come out, where we kind of walk them through step by step. Here's how you get a 1% still water elevation from a FEMA map. Here's how you adjust it to present day and future sea level using these scenarios that Maine has adopted. Map them relative to site elevations. Use either local observations of waves or FEMA designations about the type of flood zone you're in to determine whether a detailed coastal engineering analysis is needed to determine wave loads on structures, and then add freeboard that kind of accounts for all of the uncertainties that come with linear superposition of water levels like this and are in line with like local shoreland zoning requirements. A second example that I think is just the coolest, the city of Portland has redone its land use code. So after these state scenarios came out, they worked with the Silver Jackets, which is a U.S. Army Corps of Engineers group, to develop a local hydrodynamic model that modeled some of the kind of storm events of record, plus the state's adopted sea level scenarios. to create an overlay for coastal flood hazard in the city. And then they updated their zoning to say that you can, depending on the type of use you are, so maybe you're working waterfront or something non-critical like a hotel lobby versus something like housing or a school, depending on what sort of use you are, you have to elevate the first floor of your structure a certain amount above these modeled water levels that use sea level rise scenarios. All right, that was a whole lot of different topics, and end a bit early and stop there and see if you all have any questions. Thank you.
Thanks a lot, Hannah. Do you have any questions?
Patrick, I'm having trouble raising my hand, so can I just jump in for the question?
Yeah, no problem.
Okay. Hi, Han. Thank you. That was a really good description of what was going on with the work. I'm glad you gave the broad and overview. A couple quick questions. I'm not sure. And I'll just ask them both, and you can decide which one you want to pay attention to. Which is if you go back into the historical record of the Portland tide gauge, is it immediately apparent the difference between a sou'easter and a nor'easter in terms of what's dominating the extremes or the high extremes, I guess? And then the other question is there any paleo evidence of tropical cyclones having an influence on the Gulf of Maine at all? Like if you go past, and so can we say that statement that tropical cyclones have no impact at all? That's all.
Thanks. Good to see you, Chris. And those are really fabulous questions. No, it is not immediately obvious when you go into the tide gauge record, which are nor'easters versus sou'easters. One thing, kind of one of the things we're excited to do in this project is use the new NOAA Coastal Ocean Reanalysis data set where they've simulated historical events and then we can get kind of a more spatially continuous look at hopefully the non-tidal residual from nor'easter versus sou'easter events. But this is sort of so early stage that we don't even have like the step we're working on now is coming up with a way of defining what's a nor'easter versus a sou'easter and putting together a catalog of historical events. So that'll be the next step.
Yeah.
And then I'm kind of curious to separate out like what are the impacts on surge versus the impacts of surge amplification in estuaries versus waves. So it'll be kind of an
Right.
interesting,
So Cora
very
should
interesting
help with
pieces.
that.
Yeah.
Yeah.
Yeah. And then to your second question, I did a kind of a brief search for publications on that semi recently, and I didn't find anything. But if you know of anything or anyone else on the call knows of anything, I would absolutely love to hear about that.
I mean, the only thing I was thinking of was some of, and I'm blanking his name at Woods Hole, Donahue, I think, did some work on Cape Cod, right, about tropical cyclones hitting Cape Cod. So I'm not sure if that's the northern extent of where they can hit or whether they can, take some weird tracks and influence Gulf of Maine as well.
Yeah, that's Jeff Donnelly's work, and
Donnelly.
yeah, and there's been some kind of related work that has hit some back barrier coastal ponds, I think, kind of in the very southern part of Gulf of Maine, but I don't think they found any tropical cyclone records there.
Okay, thanks.
All right, Patrick, is it okay if I call people? I see Klaus, then Thomas. Klaus, you're muted. Would you mind hitting the unmute button?
Oh, thanks. It sounded like you found a lot of cooperation in the communities, but was there also some selective pushback? And how did it manifest itself, and how did you deal with it?
So in the years before I got here, my colleagues who have been working here for longer would often deal with pushback. Since I got here, I think in part because of arriving after these after sort of this string of really extreme coastal flooding events happen, kind of found that in order to engage communities to talk about flood adaptation, I don't need to talk about climate change. I can kind of talk about what's already happened. Um, and the way, but kind of speaking about what I've learned from the people who have been here longer and are experts in engaging with coastal communities with people of all sorts of kind of belief systems. They will often go into a community, and I've watched them do it. It's really great, and start the conversation from a place of what do you like about your community? What do we have in common? What do we care about? And what do we want it to look like in the future? Um, and so starting local and starting with commonalities is a way that I've seen them be able to open up difficult conversations about future planning under climate change, whether the difficulty comes from disagreement about, like local politics or broader climate issues.
Have you ever addressed managed retreat?
I have not worked on it. That is something, there's somebody named Jessica Brunicini at the Wells National Estuarine Research Reserve who's leading a lot of great work on that in this region. But yeah, that is a challenging thing to address with people who have such a deep cultural connection to the coast.
Unfortunately, I have to leave now, but I'll send you an email. I want to follow up with you, a chat message.
Thanks. I got it. I will send you an email.
Thanks. Bye.
Thomas.
Hey, Hannah. Thanks for the great talk. I'm a PhD student on the Sunny Day Flooding Project team, which does kind of some similar work down here in North Carolina. And I just like throughout this presentation, I was really impressed with how far along Maine seems to be in the whole sea level rise planning, coastal resilience space. I was wondering if you have a sense for like how Maine's preparedness in these areas compares to like other states. Like, is Maine, my sense is Maine is like relatively far along compared to other states. And then how Maine got to that point. Like, what laid the groundwork for you all to be so advanced in this space?
Thanks for the question. I am really excited to learn more about what other states are doing. Again, I'm pretty new to this work, kind of just a couple of years in. So I don't really have an answer to how we compare to other states. But yeah, appreciate the question. My sense is that I think a lot of it comes from, I think, working in communities where people have a really sort of, they know a lot about sea level and the coast. And so, and kind of interact with it on a daily basis. Kind of like everybody here knows what the tides are going to be for the next few weeks and when they're going to be. And that's a really kind of, I think having community motivation that ranges from sort of like the public to educators to legislators to business owners can really forward work in a state. I think all the work I presented, I didn't like show up and dream it up. It has really come from being here and listening to what like people are dealing with and what they want. So I think really credit goes to the community in Maine. And then I think that Maine's climate planning process has been really well done. So I didn't talk that much about the Maine Climate Council, but there's this piece where a group of scientists comes together and writes this technical report. But really what's the most important, I think, is what happens after that, where we feed that technical report to this group called the Maine Climate Council, which has everyone from like youth to teachers to business owners to legislators to like municipal leaders. Like everybody is represented on kind of every sector is represented on the Maine Climate Council. And they read this information and then like carefully craft a climate action plan that kind of considers the information. So again, I think that's a good way that Maine has gotten a pretty broad sector of the population engaged.
Yeah, that's really cool. Thanks for that and keep up the good work, y'all.
Thanks. Yeah, and if you want to like reach out and talk more, I'm familiar with a lot of the cool high tide flooding work that North Carolina does, and would also be interested to learn more about what you're doing. So feel free to connect.
So Hannah, does any of the persistent flooding have to do with like rainfall the previous season or river ice getting pushed out into the harbor or what kind of connections are there?
Yeah, thanks for that question. In some of our inland areas, so like for example, along the Penobscot River, tides like all the way up to, I don't know if you're familiar with Maine geography, but it's tidal all the way up to Bangor, which is pretty far inland. And along those reaches of river, how much ice is in the river has a big influence on flooding because it controls like if surge is trying to propagate up the river and hits an ice jam, or there's a rain on snow event and meltwater comes downstream and hits an ice jam. So ice has a really big influence. Um, you'd also asked about precipitation, right?
Yeah, just wondering, well, just as you mentioned, like rain on snow event is that something that happens more frequently now than it used to, or has it always been a persistent risk factor, or just like a little bit upstream impacts of climate change that could be influencing what's going on in the harbor?
Yeah. So by the time you reach it's hard to define like what's the coast, but like kind of the what we consider like the coastal areas of Maine, usually river effects are pretty minimal. Like the kind of discharge along our rivers is relatively low. But as soon as you even go just like a little bit inland up a tidal river, yeah, precipitation and snowmelt absolutely like have a big influence on water level. And that's something that there hasn't been a whole lot of work here on compound fluvial, fluvial, and coastal flooding. And it's something I'm very interested to work on. One thing I saw that was like super interesting that does happen along the coast, and this happened in these January events. So in Portland, for example, there are a lot of places where we have storm drains that go right from our like major roadways out to the harbor. And if it used to be that these big coastal flooding events, they usually came with snow rather than rain. But now that it's warmer, sea level rises and blocks the outfalls of the storm drain. And then you can just get these like massive rainwater backups. So major roadways that you'd assume would like, they're high and dry at a coastal flooding event. Now you're getting rainwater flooding, not because there's some spectacular amount of rain, but just because you have the stormwater outfalls blocked at the same time. So that is more the coastal influence of or the impacts of rain in coastal areas that I've seen.
Thanks.
Any other questions? I was kind of wondering about the school kids, what kind of solutions they came up with, and if that informed anything.
Yeah. Let's see. What were some of the presentations I saw? Some of them wanted to put oyster reefs offshore to attenuate wave energy. There are some who, there's a place where we have a bike path that runs around this area called Back Cove. They wanted to build a berm and elevate the bike path. Um, there were some just elevating piers. Yeah, those are kind of the ones that stuck out to me. It was really neat watching them have conversations with like our like our waterfront coordinator and sustainability manager and select board.
Okay, cool. Well, I guess if there are no more questions, we can stop there for today. So thanks again, Hannah.
Yeah, thank you all so much for listening in, and hope to follow up with some of you.